Here you are going to learn about gamma emission. Already you have learnt about alpha decay and beta decay in the class. Now I am going to explain about gamma emission. What are the various processes undergoes in gamma emission? While gamma is emitted from any radioactive element, gamma alone it won't be emitted. Along with gamma, alpha rays or beta rays will also be emitted. Alpha particle or beta particle also will be emitted along with gamma rays. Here I am going to take one typical example. You know about boron. Boron, one of the radioisotope of boron, its atomic number is 5 and mass number is 12. So let us imagine 5 boron 12, 5 boron 12, it is in the excited state. This boron, this one will emit beta particle and straight away it will come to the ground level. This is called as beta decay. It undergoes beta decay directly into the ground state and carbon will be produced. When it comes down to the ground state, boron will be converted into carbon by the emission of beta particle. So this is one of the process that undergoes. This is called as beta emission. So when 5 boron 12, if it comes from excited state to the ground state, this 5 boron 12 will be converted into 6C12. 6C12. So which one will be emitted? Beta particle will be emitted. Beta particle will be emitted. This is one of the process called beta decay. Beta particle is emitted means electron will be ejected out in the process. So electron comes out when boron 12, when it is come down to the ground state. This is one of the process of beta decay. Now we are going to see another process. Another process. Here the ground level can be taken as 0 million electron volt. The excited state can be taken as 13.4 million electron volt. So the energy of the emitted beta particle will be equal to the difference between the two energy level. So the energy of the beta particle will be how much? 13.4 million electron volt. So here just we have seen the beta emission. Are you clear? Beta particle is ejected out and boron is decayed into carbon. Now we are going to see another beta decay process. Let us take the same boron, 5 boron 12. Let us imagine this atom 5 boron 12, it is in the excited state. Its energy value is 13.4 million electron volt. Are you clear? Now what happens? This 5 boron 12 is decayed into carbon. Are you clear? Now we have to take one more energy level here. One more energy level to be taken. The intermediate energy level is here. Are you clear? This is the intermediate energy level. But it is not seen here. Directly it has come down to the ground level. But here there is one intermediate energy level. There this boron 12, it comes down to the intermediate energy level. That 5 boron 12 is converted into 6C12. Here the 6C12, it is in the excited state. This one to be called as parent element, this one to be called as daughter element. This daughter element, that one will be here for this much time. This is called as lifetime. The lifetime of the 6C12 in this excited state will be around 10 to the power of minus 11 seconds. Just I have drawn one star mark. That star mark, it shows that 6C12, it is in the excited state. This is the excited state of which one? The carbon. Now, when it is coming from here to there, one beta particle will be emitted, one beta particle will be ejected out. Therefore, we have to write E minus. One beta emission takes place here. Beta emission, beta particle will be emitted. Still, this 6C12, it is in the excited state. Are you clear? Now, the energy level of this particular level can be taken as 4.4 million electron volt. 4.4 million electron volt. Here subtract this 13.4 minus 4.4. If it is subtracted, you will get the answer as, I will write it here, 13.4 minus 4.4. 13.4 minus 4.4, that gives you how much? The difference will be 9 million electron volt. 9 million electron volt is the energy of the emitted beta particle. Now, the most important thing you are going to learn is gamma emission. In the case of gamma emission, how gamma emission takes place? Already one beta particle is emitted. The 6C12, it is in the excited state, no daughter nucleus. That one will be here in the excited state only for this duration. Now, this 6C12 will come down to the ground state. Are you clear? 6C12, it will come down to the ground state, and that one becomes 6C12. That star mark, it is only meant for mentioning about the excited state. Are you clear? The difference in energy between the excited and the ground state will be 4.4. So, here one gamma photon will be emitted. The difference in energy will be emitted in the form of gamma photon. Gamma photon. Difference between this 0 million electron volt energy level and 4.4 million electron volt energy level will be 4.4. So, therefore, the emitted gamma will have the energy 4.4 million electron volt. Already one beta particle was emitted. When the carbon 12, when it is descending down from excited state to the ground level, one photon will be emitted, that is nothing but gamma ray. Otherwise, it is also called as gamma photon. The difference between these two to be calculated, the energy of the gamma photon will be 4.4 million electron volt. So, here always gamma emission, that one takes place along with beta emission, beta decay. So, gamma emission alone, it won't takes place. Along with the beta decay, that is beta emission, gamma photon will be emitted. Are you clear? The typical equation for this process to be written now. Initially, the 5 boron 12, that one was in the excited state. That is converted into which one? 6C12. 6C12, it is in the excited state. That's why I have to put a star mark. Along with this, beta particle was emitted. That is, beta is nothing but electron. Along with beta particle, one anti-neutrino is produced. That energy also emitted, anti-neutrino. This 6C12, since it is in the excited state, what it will do? This one will come down to ground level, 6C12, along with the emission of gamma. Look at here, when it comes down from excited to the ground level, there is no change in the mass number and atomic number. Same element, no change in the element, but gamma is emitted. The energy difference between the excited state and ground state, that difference, that gives you the energy of the emitted gamma. So, this is called as gamma emission. So, this is the typical equation. Now, I am going to write the general equation. For this particular transition, I can write the equation x. What is x? Element in the excited state. Z x a. Let us imagine 6C12. Same thing is written in common form, Z x a. That is come down to ground level. It is in the excited state now, that is why we can put star mark. Now this one becomes, it comes down to the ground level, therefore we can write the same x. No change in the mass number and atomic number. But which one is emitted? Gamma is emitted. Gamma photon will be emitted. Are you clear? So the only thing is the transition takes place from excited to ground. No change in the mass number, no change in the atomic number. Same element finally you will obtain. The energy level alone changes. This is called as gamma emission. Here gamma emission is not mentioned. Directly boron, it comes down to ground level and it emits beta particle. No gamma emission takes place. This is one of the possibility. This is another possibility in which gamma is emitted. Okay, thank you.